see it?
Yes.
This is a good activity to use in the beginning when you start, because everybody will get different answers for different, so the Z-scores in the end.
We did one, I can't remember if it was this.
I feel like I remember the day that I was
Detail. I think that maybe the same thing, but it's a different page, but I'm pretty sure but see, this is back in chapter 1.
Right,
So they're
right.
having to remember.
So it's a good one to do then today to remind.
That's right. I need that back.
Alright, so let's everybody get the models written down on our paper here, because you're going to have to take the model and your percentage in just a minute and give me a Z-score. Bless you.
Yeah, but that's just gonna take more.
Alright, so let's get our model sketched off here. Alright, now, when they're asking you to do Z-scores, or they are asking you for percentiles as far as where your data falls, I make every student I have draw quick sketches. If you're going to do a percentile or if you're going to do a Z-score, again, from the grading point of view, if it is a free response, a picture says a lot, an awful lot. Now, it doesn't have to be as detailed as what we have up here, but a quick sketch says a lot about what you know how to do. Now, my percent of M&Ms was 20%. So I'm interested in what is the Z-score, my Z-score, because if you go on down here a few problems down, it asks you what's the Z-score for your percent of blues and your percent of oranges. So on my blue, 20%, if we're looking at our model over here, is between the mean and +1 there, which is 0.189. Now again, on the AP test, I'm making my students draw in where they're labeling their 0.20 there, and they're shading in, because I'm interested in what is the Z-score for 0.20. And so, you know, your Z-score, formula-wise, is your X value minus the mean over the standard deviation. So everybody ought to be able to plug in your X value, which mine was 0.2. The mean for everybody is 0.23. And what was your standard deviation over there?
0.041.
0.041 was our standard deviation. So everybody ought to be able to get their Z-score associated with whatever your value was. Now, go ahead and convert that to see what percentile or what percentage you are at compared to the whole class. Now, how do you do that? How do you change a Z-score to a percent? Do we remember?
Do we remember?
So what was your Z-score? Let me do mine.
Mine was 0.48.
Like the mean, yeah.
So mine is 0.2.
Get drawn.
Mine is 0.23. Divided by 0.041.
It was so bad.
And then the next question is it positive or is it negative? Because remember, z-scores are both positive and negative. Now, for me, my z-score up here is negative 0.731, which is where I'm sitting. I'm not quite to -1 standard deviations here. So my z-score sitting right there is negative 0.731. So everybody in here ought to have a z-score. Now, what's the area under the curve that corresponds, or the percentage that corresponds to that z-score? Now, you're either going to be using the back of the book, or you're going to be using your calculator. Again, which should we do?
We already both.
Calculated.
But
Well,
yeah,
I like the
prefer
calculator too,
calculator.
but I've got students who really like to use the back of the book, so I'll leave that to them. So somebody tell me, this is my x value, and my z value here is negative 0.731. So how am I going to change that to see at what percentile I'm located at? How about, in calculator under distributions, second bars, you have these things called normal CDF, and then you have this thing called inverse norm. Which one of those do you use to calculate the area under the curve?
Inverse norm.
Do which one?
Inverse norm? No, I don't know.
Well, let's do this. Push inverse norm and see what it asks you for.
Lower, upper, and your mean and standard deviation.
It asks for all that when you push inverse norm.
Oh, sorry, no, normal CDF, my bad.
When you push inverse norm, it asks you for the area under the curve, right? So that's not going to give you a percentile. That's going to give you a z-score or an x value, okay? So that means we are interested in normal CDF. We're wanting to accumulate, that's what the C stands for, the cumulative density frequency. We're wanting to accumulate the area under the curve. All right, so if we select that, then we're looking for our upper and lower bounds here. Did y'all put them in both ways? With the did you use standard normal model? Did you put in Z's or did you put in X values?
I think we put in X values.
Okay, so depends on how you're taught. I'll make mine do Z's first. But if you want to know the area under the curve, if we're talking about using the standard normal model, which generally is what pops up on your calculator, it says lower, upper, and it says mean, and then it says standard deviation on here. Now, it generally pops up 0 and 1. Now, if 0 and 1 are on here for the mean and the standard deviation, then that means you're going to have to put in the z-scores in here. If you, however, want to use your x values, you have to put the mean and the standard deviation from the problem in there. So just make sure you're putting the right information in there. Now, since we've got a z-score, let's use our z-score first. So in this particular problem, my area goes forever in the direction to the left. So my lower boundary here is negative 9999999. So I would put in there, or your calculator pops up what? -1 exponent to the 99. That's perfectly fine as well, but you got to have some very, very low value here that you put in. Your upper value here is the z-score that we found, you found. And so my z-score for me was a negative 0.731. Now again, when you're putting the z-score in there, you must have a mean of 0 and a standard deviation of 1, because that is called the standard normal model. You're standardizing it. Alright, and so then you just go down there and hit paste. And it's going to give you, hopefully, the value that you were looking for, your percentage there. So 23% of the time, or my value that I got, an X value of 20%, is at the 23rd, for me, it's at the 23rd percentile. So you're looking at your calculator and seeing at what percentile your percent blue is at. Now, if you use 0.20 here as your upper bound, then you must put in 0.23 as the mean, and you must put in 0.041 as the standard deviation. Now again, you need to know how to use it both ways. Mainly because of time factor. You know, the AP tests your time. And so sometimes it's just quicker to enter in the X stuff than it is to get to the Z score. It just depends on what they're asking you for. So plug in what you need. Now, what I'd like for you to do is do the same thing with your orange one. Find your Z score for your orange, and then figure out at what percentile your orange value is for this whole class. Where are you in comparison to everyone else in the room? Where did your percentile fall? Now I know it didn't ask you for percentiles, but I like to throw percentiles in. Yes, ma'am. Okay. Okay, so you were 26%. Okay, so you're way up here. So you're zero. No, you're right there. Your X value is at 26%.
Hey, Lee, no.
Yeah, because you're coming up to that point. Because you're better than all of these values. So that would be your percentile. Well, for the negative one, you put down 30 here. So you should have it. So you can put negative one negative, and shake that way.
Where are you going?
Okay, so
I live
in the area behind.
I live on the 18th. Where are you going? Dominican?
Up to this
I'm
point.
going to Thomas.
What time is your? Oh wait, that's not. I would say we're done for
Anybody else got questions about shading, filling in? You hadn't done it in a while, so you just forget. Okay. Okay, so 0.24 says that you are sitting. Oh, we're on this graph. Okay. How'd you get a negative? Oh, that's your blue. I'm looking at that number. What's that? Okay. I'm with you now. All right, so 24 is in here, obviously, right? So this because orange. Yes. Okay. It just didn't look right to me. Okay. So let's get that done. That looks much better. Because I'm looking right here. So that. And it's telling you it's 0.8, which makes sense because this is 1. That, I could not say to look at right there. Now, what you are interested in is the area up to that point. And so what that's telling you, when you get that area of the curve, that tells you where your percent of orange is compared to everybody else in the class. Alright, so let's go to second bars. And go to normal CDF. Right? So lower is, where's the edge of my shape? It's going this way. So the lower is negative, no.
I think about you like once every 3 months.
That's the, yep. And the upper is going to 6.8. Okay, so you are around that's the 80th percentile. So you are better than, your count of M&M's is greater or than the 80% of this class. Okay, that's what that's telling you. Okay?
Yeah, that. That's right.
Okay, so you're
If I try to if she did
I didn't really want to
no. So you're at the 23rd percentile, which says you're better than 3% of the class. Okay? All right. Anybody else need help with that? I mean, now's a good time to talk about it. Yes, ma'am. So that says, so your number of orange meals is greater than 48%. Okay, that's what it's telling you. Anybody else we need to talk to? Do what?
I think we're good.
Good. Now, again, these are the things that they expect you to be able to do on the AP test with a normal model.
Y'all.
That's what they're looking for, is that you can walk yourself through. And a lot of times the question is just going to be straight out, what's the percentile? And so you're going to have to know in your mind that you got to go kind of through all of this to get to the percentile or where you are. Now, on the other hand, they may give you the percentile, and they may ask you what's the X value or the Z-score associated with that particular percentile. So you can go forward or you can go backward, and chances are you'll have to do both on the AP test. Come on in. All right, let's go look at a couple of multiple choice questions on our normal model. So just kind of slide over there just a little bit. M&M's. And let's go look at a couple of these multiple choice ones. Okay, so a couple of things about the normal model that you should know. The shape is unimodal, it's symmetric, and it's mound shaped. Now, one thing you do need to keep in mind is that there's just not one picture of a normal model. It could be short and spread out, or it could be pushed in and really tall. And again, if it's short and spread out, that's telling you you got an awful lot of spread going on or a big standard deviation. And you need to be aware that it's more than one graph. It's not just one individual graph. It's multiple graphs in a lot of different ways. All right. If it is normal, you would expect the mean and the median to be equal. A normal model is continuous, although it is often used to approximate a discrete distribution, kind of like a histogram does. Go back, what that was. Oh, this is important. I don't know if you guys talked about it, but that is the standard notation for a normal model, and that comes up on the AP test quite a bit, that they will just have the capital N, and then in parentheses, they'll have two numbers, and you have to know that that first number is the mean, and the second number is the standard deviation. So that's a notation that may show up. Some textbooks don't show you that notation, but it is on the AP test like that. So make sure you know that that's a big N, meaning normal model. First number is the mean, second number is standard deviation. All right, the empirical rule, now these are the ones that you're supposed to know already. The percentages for about 68% of the areas within one standard deviation. So again, between plus and minus 1 is about 68%. 95% is between minus 2 and plus 2. And then 99.7% is between plus 3 and minus 3. They expect you to know that one by heart. You'll get asked questions about that one. So you need to know those percentages for that, for the empirical rule. Z-score, we've already talked about, but again, it's your X value minus the mean over the standard deviation. You actually used that already. Z-scores make it possible to compare quantities. And you know, a lot of times on the AP test, they're going to ask you to compare two different things. Lots of times it shows up like you want to compare a basketball player, say, to a football player. And so you convert them to Z-scores, and you can tell which one is the better one in their particular field. So that happens an awful lot. We just got through doing all that, so doing all that. So let's look at our multiple choice here. All right. So number 1 says this: if the heights of third graders follow a normal distribution with a mean of 52 inches and a standard deviation of 2.5 inches, what is the Z-score of a third grader who is 47 inches tall? Now, first thing you should do is write down that Z-score formula and look at it. If it's talking about Z-scores, then we probably should write the formula down. What is the Z-score? You have a mean of 52. Again, X bar is the mean. 2.5 is your standard deviation. And your X value that you are interested in there is 47 inches. So we would like to know what is the Z-score of that particular third grader.
-2.
There's our formula if you've forgotten. Again, you know, most formulas that you need for this AP test are on the formula sheet, but the Z-score is not on there, and finding the fences for IQRs is not on there either. So there's a couple of formulas you just have to know, and this is one of them, along with doing outliers. All right, so yes, it is -2. Did we all get -2? Okay, let's go one step further. At what percentile is this third grader at if she is 47 inches tall? What percentile is she at? So what are you going to do to figure out at what percentile this 47-inch tall fourth grader would be? Now again, we just did that. So you're plugging that in your calculator. You're going second bars, and you're going into normal CDF, to see where is 47. Well, it's less than 52, so you know it's going to be less than 50%. If you're again, my students would never work this problem without sketching this out quickly. And when I say quickly, I mean they would draw a quick model here. They would put 52 in the middle, and they would put 47 right there, and they would shade it in. I mean, I require them to do that. I mean, that's all they have to do. But I do require them to do that because, again, I know what the AP graders are looking for. They're looking for some proof for this if it is a free response question. So you are plugging in that it's coming from negative 99999 up to this Z-score that you have found of -2. And so what percentile is this particular third grader at? What'd you get? Punch it in the calculator, so what you get? 0.27? Okay, so she's at the 27th percentile. You should get a decimal answer here. You got what? Say it again. 0.0.
2275.
Okay, so thank you. If we move this decimal twice, she's only at 2%. You would hope she'd be a little bit better than that, because she's only better than 2% of the people. Did you get that? She's not quite, you know, when you go to the doctor's office, or when you were a child, when you went to the doctor's office, he's going to look at you and say, you're in the 50th percentile, which says you're better than 50% of the students, 50% of the students, kids your age. And your parents are like, okay, so you're average. This kid's not average. He's only, or yeah, the poor kid's not very tall. But, you know, if they tell you you're at the 98th percentile, then you're taller than 98% of the kids who are at this particular age. So you need to be able to interpret what all that kind of stuff means together. All right, let's go look at question 2. All right, I'll let you read that. Let's hear from some of you folks in the back there. What do you think?
I got D.
So I got D. Anybody else get D? Got a couple more D's here. D is correct. You are correct. You had a pH of 1.8 standard deviations higher than that of average rainwater. Yes. All right. Number 3. Now, this is taking you back to your empirical rule to see if you know that empirical rule. Have we got a thought here? C?
C.
C? C is correct, yes. Questions about that? Very good, you're just stepping off those standard deviations. All right, 4. Now, again, this is one of those that you gotta be real careful about, because you got 1, 2s, and 3s. All right, we got a thought? Which one? B as in boy or D as in dog? D as in dog? C?
One is true, one is
I said D.
One is true, yes. So what else is true all the time?
3.
3 is true all the time. So our question then is about 2. Is 2 true all the time?
No.
No, it's not. Because not all symmetric distributions are normal models. Now, normal models are symmetric, yes, but not all symmetric distributions are normal. All right, number 5. All right, this is one that's kind of asking you about percentiles or percentages here. Okay, so I missed your break time, so shoot me. So you got a 5-minute break right here. Do be quiet if you go out in the hall to go to the bathroom or something, because the other folks are already back in class. I just having so much fun, I forgot. So 5 minutes, and we'll come back and talk about this one, okay? But be quiet in the hall. You don't want to disturb anyone.